Welcome to our channel. Let's begin the journey.
Today, we're going to unravel one of the absolute greatest scientific detective stories in human history. We are focusing on a monumental turning point in astrophysics, the moment Edwin Hubble, spending countless nights at the Mount Wilson Observatory, discovered the Andromeda Galaxy and the cosmological redshift. It was the ultimate empirical proof of the expanding universe. It's a truly wild story full of incredible minds, freezing nights at a massive telescope, and the beautiful underlying physical laws that govern literally everything we know. Let's dive right in.
So ask yourself this question. Has the universe just always been here, sitting forever in a steady state, or did it have a definitive, violent beginning? For thousands of years, this profound philosophical question absolutely haunted humanity. I mean, the premise sounds simple, right? But the implications are staggering. If the universe has just always been here, completely steady and unchanging, well, then it doesn't need an origin story. But if it had a violent beginning, then it's an evolving, living entity with a distinct birth and possibly a death. And for the longest time, science and philosophy just had no rigorous way to answer this.
Up until the 1920s, the vast majority of the scientific world found immense comfort in the classical view, a totally static, unchanging model of the universe. To them, the Milky Way galaxy was all there was, the whole shebang. But hiding quietly in the math of the era was a radical new theory. This was a really bold claim, proposing that the universe was not standing still at all, but was actually actively expanding outward from a single primeval atom. Now here's where it gets kinda crazy. The new revolutionary math of general relativity actually possessed the framework for a dynamic, moving universe. But Albert Einstein himself clung to the incredibly stubborn illusion of a still cosmos. His equations beautifully unified space and time into a single, flexible fabric, and mathematically, they naturally pointed right to a moving universe. Yet this was so deeply contrary to the accepted norm of the time that Einstein actively resisted the terrifying implications of his own math.
And this quote from the prominent physicist John Wheeler brilliantly illustrates the core of relativity, the underlying physical laws that the old static model was fundamentally failing to embrace. He said, "Matter tells spacetime how to curve, and spacetime tells matter how to move." See, gravity absolutely isn't some mystical, invisible pulling force. It is simply the physical curvature of the fabric of spacetime itself. Massive objects create deep dents, and other objects just slide gracefully along those curves. So if absolutely everything is curving and interacting, how could the entire cosmic system possibly just sit perfectly still? Well, it simply couldn't.
So enter Georges Lemaitre. He was the very first person to aggressively challenge the static universe assumption using Einstein's own equations, and he boasted a seriously fascinating resume. He was a devout Catholic priest, and at the exact same time, a staggeringly brilliant theoretical physicist. In the 1920s, while the rest of the scientific community was totally comfortable with an unchanging cosmos, Lemaitre sat down, independently solved the highly complex equations of general relativity, and arrived at a deeply shocking conclusion. Let's look at Lemaitre's radical blueprint. He basically built a completely new conceptual framework for reality. He bravely used his intellect to hit rewind on the tape of cosmic time. He argued quite masterfully that if things are moving apart right now, they mathematically must have been much closer together in the past. And if we dare to rewind that timeline all the way back to the very beginning, the entire mass and total energy of the whole universe must have once been violently compressed into a single, infinitely hot and dense point. He vividly called this singularity the primeval atom. As you might guess, Lemaitre faced a massive brick wall of skepticism from the scientific community. It actually culminated in this incredibly harsh critique directly from Einstein himself. "Your mathematics is undeniably great, but your physical intuition is abominable." Ouch, right? When Lemaitre formally presented his revolutionary idea, the scientific elite pushed back so hard. But you know what? Lemaitre steadfastly refused to back down. He persistently and eloquently defended his physical perspective against literally the greatest mind of his era. However, as we all know, science demands that we never operate on pure belief alone. No matter how incredibly beautiful and mathematically elegant Lemaitre's theory of a primeval atom was, his theoretical blueprint desperately needed concrete observational proof to survive. It needed to be tested in the real world. To turn this from paper equations into undeniable reality, we needed a definitive observer. We needed our lead detective to look deeply into the dark. And that brings us to the meticulous Edwin Hubble. He utilized what was the world's absolute largest telescope at the time to scan the deep, endless void of space. Hubble was an intensely focused, ambitious guy. He worked tirelessly, enduring long, freezing, and incredibly lonely nights up at the famous Mount Wilson Observatory in California. He was completely determined to find the empirical data that would finally settle this ultimate debate about the true nature and scale of our universe. So, how did he do it? Let's break down the breakthrough step by step. First, he focused his massive telescope straight at the Andromeda Nebula. Second, he searched for extremely faint Cepheid variable stars. Thanks to the brilliant earlier work of Henrietta Leavitt, astronomers knew these specific stars pulsed at regular intervals based on their brightness, basically acting like cosmic yardsticks. Third, because these stars appeared so unimaginably faint, Hubble calculated the distance and realized it was impossible for them to be inside our Milky Way. Boom! Andromeda was actually an entirely separate, unimaginably distant galaxy.
Finding out that the Milky Way was just one of many galaxies in a vast ocean of space was a massive paradigm shift all on its own. But Hubble didn't just stop at discovering that new galaxies existed. Driven by sheer ambition, he pushed forward to rigorously analyze the specific light emanating from these newfound, infinitely distant galaxies. He wanted to know exactly how they were behaving out there. And when he looked closely at their light spectrum, he noticed a highly strange, consistent phenomenon.
I really want you to focus on this definition right here, cosmological redshift. This phenomenon provided the ultimate empirical proof that completely shattered the old static worldview. Hubble observed that the ancient light coming from almost all of these galaxies was noticeably shifted toward the red end of the spectrum. It's a direct result of the Doppler effect. Think of it exactly like the physics that makes an ambulance siren drop in pitch as it drives away from you. Out in the vastness of space, this redshift definitively proved these distant galaxies were physically moving away from us.
And then he found the linear rule. This is literally the linchpin of our modern cosmology. As Hubble compiled vast amounts of astronomical data, he discovered a strict, unyielding rule. The farther away a specific galaxy is located, the faster it is flying away into the void. These galaxies aren't just aimlessly buzzing around in static space. This rule definitively proved that the physical fabric of space itself is actively expanding outward in all directions. So what are the consequences of Hubble's proof? The sheer monumental impact of these discoveries really cannot be overstated. He firmly established that absolutely everything in existence is drifting apart. His observations officially killed the old, comforting, static universe model. They fully validated Lemaitre's blueprint of a primordial explosion, what we now universally call the Big Bang Theory. It completely, fundamentally, and permanently changed how humanity conceptualizes our vast cosmic home. As we wrap up this incredible journey of discovery, tracing the path all the way from Lemaitre's bold equations to Hubble's freezing nights at the Mount Wilson Observatory, I'll leave you with this mind-bending thought. We now have an accurate map of an expanding universe, governed by beautiful underlying physical laws. But if the physical fabric of space itself is actively growing and stretching outward every single second of every day, what exactly lies beyond that expanding edge? What is it expanding into? It's a profound mystery to ponder the next time you look up at the stars. Thank you so much, and I can't wait to dive into our next cosmic topic with you soon.
The view from here is breathtaking. Command, we are in position and ready for the next phase. If you liked the video, subscribe and comment the topic you want next. Thanks for watching, and stay unstoppable.